Today we are going to starting the articles carries 1 or 2 marks of the subject physics related to 12th HSC board exam. Whatever points we are covering here all are related to 1 or 2 marks. After these points we will see also the articles which carries 3 to 4 marks. So let us see about the 1 or 2 marks articles. Okay. The very first article from the first chapter rotational dynamics named as circular motion. The very first article that is named as circular motion. Okay. Circular motion, it is defined as the motion of a particle. It is nothing but the motion of a particle. You can say the motion of an object, or you can say the motion of a body along circumference, the motion of a particle along circumference of a circle is called as circular motion. Where the motion takes place, the motion of a particle along circumference of a circle, it is called as circular motion. The most important point about circular motion is that in circular motion the speed does not remain constant. It means the speed or the velocity, it varies. For example, we can say that in which the speed does not remain constant, we can say motion of blades of a fan. Motion of blades of a fan. We can change the speed of a fan. We can keep it on 1, 2, 3, 4 or 5. It means here the speed does not remain constant. We can vary the speed. Of the same type, motion of tips of a hand clock. Motion of tips of a hand clock. Okay. The motion of tips of hand clock also varies. Whatever time I have in my hand watch, the same will not be in your. It varies. It will be in varying form. That's why it is said that motion of tips of a hand clock. Thus from this we can conclude that circular motion, it is the motion of a body or the motion of an object or the motion of a particle along circumference of a circle in which the speed does not remain constant, called as circular motion. Of the same type, that what do you understand by the term uniform circular motion? Uniform circular motion. The term uniform, it itself tells us that here somewhere the uniformity takes place. Where the uniformity, we are well familiar about circular motion. The motion of a particle along circumference of a circle. Same here. But what is the change is that the motion of a particle, the important thing is that with a constant speed. This is the difference. You have the definition on the blackboard. What is the difference? We are observing that the motion of a particle here along circumference of a circle, but here the motion of a particle with a constant speed. Here the speed is constant, with constant speed, where along circumference of a circle, along circumference of a circle, then it is called as uniform circular motion. So what we can conclude that about circular motion and about uniform circular motion? In circular motion, speed does not remain constant, but in uniform circular motion, the speed remains constant. So what we can say about the example? We have to write such is the example that at which the speed does not vary or the speed does not changes. For example, the best example is that the earth revolves around the sun. The earth revolves around the sun. The speed of earth is constant. Okay, and where the earth is revolving around the sun, at which the speed is remains constant. The best example is that the moon revolves around the earth. Okay, here again the speed remains constant. Here the speed does not remain constant. So what is the difference of circular motion and uniform circular motion? In circular motion, the speed does not remain constant, whereas in uniform circular motion, the speed remains constant. Okay, so first of all, see these 2 points. Okay, then we will conclude the another one. Watch it first. So after these 2 definitions of circular motion and uniform circular motion, let us consider the another important point, that is, what do we understand by the term radius vector? It is also named as, in sometimes it is also called as position vector. What do we understand by radius vector or position vector? To understand this, let us see the diagram. Number of things or major things in physics related to diagram. Here is the point that we named as the center. Okay, from the center, what I am doing, I am drawing a line. What we are seeing here, that we are drawing a line from where? From center up to a point on the circle. Just draw a line from center up to a point which is situated at the center. So what we can say? Radius vector, a line drawn from center of a circle. A line drawn from center of a circle to position of a particle. Is called as, this is called as radius vector, or you can also call it as position vector. You can represent it as r. So what is r? R is called as radius vector or position vector. How we can say? It is the line which drawn from, जिसको आपने draw किया, which drawn from center of circle to position of a particle. It is called as radius vector or position vector. Okay, it is measured in meter. Okay, then after that, again consider the same diagram. Let us consider another diagram. You have the center, you have the radius, a point P. Okay, here the point P. Let us consider point P or a particle or an object which is moving in anti-clockwise direction. Okay, we are going to discussing about the article that is called as angular displacement. What we are going to discussing about angular displacement. So to understand the concept of angular displacement, the diagram, okay, in the diagram will be the center, P be the point or a particle situated at a distance r. That distance r is called as radius vector or position vector. After certain time, point P reaches to point A. After certain time, point P reaches to point A. So just join this. What about the point OA? This point OA is called as again radius. Okay, and it makes a certain angle theta. You can say d theta. You can say delta theta. So how the angle here makes here? How this theta takes place? If point P moves from point P to point A, if point P is moving from or it changes its position from P to A, then what happens? It makes a certain angle theta. So we can say that angular displacement, angle made by radius vector, angle made by radius vector. Yes, this theta be the angle. Who is making this angle? This angle is made by this radius vector. That's why it is said that the angle made by radius vector with a position of a particle. The angle made by radius vector with position of a particle with a respect to time. With respect to time. It means that with increase of time, okay, with increase of time, here P is moving from P to point A. That's why some angle is made there. So we can say that here angular displacement, angle made by radius vector with the position of a particle or with respect to time is called as angular displacement. It is called as angular displacement. It is denoted by sometimes theta, okay, or it is denoted by the factor d theta, or it is sometimes denoted by the factor delta theta. It is measured in radian, represented as only rad. Okay, it is measured in radian, which is represented as only rad. Okay, so what we have seen here, starting from the name of the article, radius vector. How the radius vector takes place? Just draw a line from center of a circle to position of a particle. A line drawn from center of circle to position of a particle is called as radius vector or position vector. What do we understand by angular displacement? Angle made by, थीटा भी द एंगल मेड बाय, इस एंगल को किसने बनाया? रेडियस वेक्टर ने बनाया. द एंगल मेड बाय रेडियस वेक्टर with respect to position of a particle or with respect to time, called as angular displacement, generally represented by the factor theta, sometimes d theta or delta theta, and it is measured in radian. Okay, watch this first. Now let us consider another important, that is point called as angular velocity. Another important point that is called as angular velocity. Okay, what we can say about angular velocity? The simplest definition of angular velocity is that rate of change of angular displacement, rate of change of angular displacement with respect to time. What we can say about angular velocity? A rate of change of angular displacement with respect to time is called as angular velocity. Okay, so what is angular velocity? Angular velocity is nothing but rate of change of angular displacement with respect to time is called as angular velocity. It is denoted by the factor omega. Okay, it is denoted by the factor omega. Okay, full stop. It is written as that is omega is equal to limit delta t tends to 0 delta theta upon delta t. It is denoted by the factor omega. If we are writing in the form of limit, we can write in this way: limit delta t tends to 0 delta theta upon delta t. What is delta theta? The angular displacement. A rate of change of, here the factor d, the factor delta, these are the factors in physics related to change, rate of change of. Here what is going to change? Here theta, that is called as angular displacement, is going to change. You can write rate of change of angular displacement, that is delta theta upon delta t. If you are writing in the form of limit, you can write in this way, that is in the form of delta. Omega is equal to limit delta t tends to 0 delta theta upon delta t, or you can write also in the form of d, that is omega is equal to d theta by dt. Again, what is the factor d stands for? D also stands for change. What is going to change? Theta. What is theta? Is the angular displacement. So what we can say, angular velocity is nothing but it is the ratio of change in angular displacement with respect to change in time. जैसे जैसे समय change होता जाएगा, angular displacement it also goes to changes. That's why it is said that angular velocity is nothing but it is the ratio of change in angular displacement with respect to time. Measured in, it is measured in radian per second. Angular velocity is measured in radian per second. It is a vector quantity. These are the points sometimes asked for 1 mark, that what is the unit of angular velocity. We have the 1 mark place in our HSC board exam. Sometimes it may also ask what is the unit of angular velocity. Okay, which quantity angular velocity is, whether it is scalar or vector. Angular velocity, it is a vector quantity. What is its unit? It is measured in radian per second. What are its dimensions? Its dimensions are, we have to write in the form of square bracket. Dimensions generally written in square bracket in the form of MLT. M stands for mass, L stands for length, T stands for time. Here there is no information about mass, so the power of M is 0. No information about length, breadth, so the power of length is 0. But we have the information about the time, that is to the denominator. When it comes to numerator, it becomes -1. So what is the dimension of angular velocity? Angular velocity, it have the dimensions m raised to 0, L raised to 0, T raised to minus 1. What we can say about angular velocity? Angular velocity, the rate of change of angular displacement with respect to time, called as angular velocity. It is denoted by the factor omega. Okay, it is mathematically written as, if we are writing in the form of delta, we can write in this way: omega is equal to limit delta t tends to 0, delta theta by delta t. If we are writing in the form of d, we can write in this way: omega is equal to d theta by dt. What the factor delta and d stands for? Delta and d stands for change. So we can say change in angular displacement with respect to time. Also again change in angular displacement with respect to time. That is nothing but angular velocity. It is generally measured in radian per second. It is a vector quantity. It have the dimensions m0, l0, t raised to minus 1. Okay, watch it first. Now after angular velocity, let us consider that what do we understand by the term angular acceleration. What do we understand by the term angular acceleration? Very simple way, again we are defining about angular acceleration. Angular acceleration, it is the rate of change of angular velocity. What we can say about angular acceleration? It is the rate of change of angular velocity with respect to time. Okay, what is angular acceleration? It is the rate of change of angular velocity with respect to time. Okay, it is denoted by the factor. It is denoted by the factor alpha. Okay, it is denoted by the factor alpha. It is written as two-way, as we already seen angular velocity in the form of delta, also in the form of d. Same, first of all in the form of delta, that is vector alpha is equal to limit delta t tends to 0, delta omega upon delta t. That is delta again stands for change in omega. Omega means angular velocity. Change in angular velocity with respect to time, called as angular acceleration in the form of delta, or in the form of d, that is vector alpha is equal to d omega by dt. Alpha is equal to d omega upon dt. Again d stands for change. So what we can say, change in angular velocity with respect to time, called as angular acceleration. Okay, it is measured in radian per second square. Next point, it is a vector quantity. It is also a vector quantity. What about its dimensions? Its dimensions are once again in the square bracket in the form of MLT. Mass, no, that's why the power of mass is 0. Length, its power is 0. Second square to the denominator, when it goes to numerator, so the power of time t is minus 2. So dimensions of angular acceleration are m raised to 0, l raised to 0, t raised to minus 2. So what we can say about angular acceleration? Angular acceleration, it is nothing but it is the rate of change of angular velocity with respect to time, generally denoted by the factor alpha. Mathematically can be written as alpha is equal to limit delta t tends to 0, delta omega upon delta t, or alpha is equal to d omega by dt. So what we can say in simplest way, what is angular acceleration? It is the ratio of change in angular velocity with respect to time. Okay, measured in generally radian per second square. It is also a vector quantity and its dimensions are m0, l0, t raised to minus 2. Okay, watch it. Now the another important article that give the relation between linear velocity and angular velocity. It's the important article. Number of times it is asked for 2 marks. Okay, relation between linear velocity and angular velocity. Let us consider the following diagram to understand the relation between linear velocity and angular velocity. Let us consider the following diagram in which O as a center, from the center a particle A is situated at a distance r. It is moving in anti-clockwise direction, performing uniform circular motion. Okay, as it is in moving condition, so after certain time obviously it reaches to another point that is named as B. When A reaches to B at that time, it makes a certain angle theta. That angle is called as, we named it as, it is called as angular displacement. Okay, as A is in anti-clockwise direction, it means it is performing uniform circular motion. So when it reaches to point B, it also covers a certain displacement delta x, that is called as linear displacement. That delta x is called as linear displacement. Okay, as shown in the figure. So what we can say, we can write in this way that in the figure we can say, in the figure a particle A moving in anti-clockwise direction, performing uniform circular motion. In the figure there is a particle A moving in anti-clockwise direction, performing uniform circular motion. Okay, covers certain displacement delta x in a time. It requires certain displacement, so for that displacement it requires certain time, that is represented by the factor delta t. Okay, particle is covering certain displacement delta x, requires certain time, that is delta t. Okay, it makes certain angle delta theta. Okay, that is called as angular displacement. Okay, that theta is called as angular displacement. Okay, having certain radius r as shown in the figure. Okay, in various way we can explain the paragraph from the diagram. What is shown in the diagram? In the figure there is a particle A moving in anti-clockwise direction from point A to point B covers a certain displacement delta x called as linear displacement. It makes a certain angle theta called as angular displacement. To move from A to B, it requires a certain time that is represented by the factor delta t. O as a center, R as a radius, as shown in the figure. Okay, from the geometry of figure, from the geometry of figure, we can write that is delta theta is equal to delta x upon r. How this is? The geometry tells us that delta theta is equal to delta x by r. If we take cross product, we can write that is delta x is equal to r delta theta, equation number 1. How it takes place? From the geometry, delta theta is equal to delta x upon r. Taking cross product, delta x is equal, what it becomes? It becomes r delta theta. This is equation number 1. We know that particle A is performing uniform circular motion. It means it has certain velocity, and velocity is nothing but it's the ratio of linear displacement. What do we understand by velocity? Velocity is nothing but it is the ratio of linear displacement with respect to time. Mathematically, it can be written as velocity v. In the term of limit, we can write v is equal to limit delta t tends to 0, delta x upon delta t. Okay, in the form of mathematical, we can write v is equal to limit delta t tends to 0, delta x by delta t. But what do we understand by this delta? We have in equation 1 its a value. So what we can write? Put a delta x from equation 1. Put the value of delta x from equation 1. What we can write? We can write that is v is equal to limit delta t tends to 0. What is the value of delta x? It is r delta theta. Okay, it is r delta theta upon delta t as it is. It is the important point that we have already written here that the particle is moving in anti-clockwise direction performing uniform circular motion. Uniform circular motion in which the speed remains constant. Okay, and the radius also remains constant. So here is their radius. Take the radius outside the limit. Why? It is the constant factor. So we can write that is v is equal to r limit delta t tends to 0. What remains? Delta theta upon delta t. What do we understand by delta theta? Delta theta is called as angular displacement. And what is t? It is the time. So the ratio of angular displacement with respect to time, it is called as angular velocity. So what we can write? That is v is equal to, okay, v is equal to r omega. What is omega? Omega with the angular velocity. And what is angular velocity? It is the ratio of angular displacement with respect to time. The ratio of angular displacement with respect to time is called as angular velocity, and it is written as omega. So what we have got here, v is equal to r omega. This is the required relation. This is the required relation in between linear velocity and angular velocity. In vector form, we can write it in this way. If we are writing in vector form, it becomes vector v is equal to vector omega cross vector r. How? This is in vector form. If question asked, write the relation between linear velocity and angular velocity in vector form, we have to write it in this way. That is vector v is equal to vector omega cross vector r in vector form. Okay, so watch it carefully. Now the relation between linear acceleration and angular acceleration. Okay, To obtain the relation between linear acceleration and angular acceleration, the best way or the simplest way is that we have to write, let us consider, we know that the relation between, linear velocity, we know the relation between linear velocity and angular velocity. So what we know, that is v is equal to r omega. Okay, so to obtain the relation between linear acceleration and angular acceleration, in the simplest way we have to write, we know that the relation between linear velocity and angular velocity. Okay, differentiate, just differentiate the above equation, differentiate the above equation with respect to time. Differentiate, it means to write in the form of d by dt. Differentiate, it means to write d by dt. So what we can write, differentiate, that is dv upon dt is equal to d by dt of r omega. Just watch it carefully, see, v is equal to r omega. Just differentiate the above equation with respect to time. Differentiate, it means to write d by dt, that is d by dt of v, d by dt of r omega. dv by dt, we write it as it is. What do we understand by r? R is the radius and it is remains constant. So take the constant factor outside the derivative. So r into d omega upon dt. What we get? dv by dt is equal to r d omega by dt. What do we understand by this factor dv by dt? This is nothing but, it is called as change in velocity. What is this? This is change in velocity with respect to time. Okay. What is this factor d omega by dt? This d omega by dt is called as change in, it is nothing but change in angular velocity with respect to time. And we are well familiar that, what we are well familiar? We are well familiar that change in velocity with respect to time, it is called as acceleration. It is called as acceleration. Radius factor as it is. What do we understand by change in angular velocity with respect to time? It is called as angular acceleration. Okay, acceleration, it is denoted by the factor a. So a is equal to r. Angular acceleration, it is denoted by the factor alpha. So what we get? A is equal to r alpha. So this is the required relation. This is the required relation about, this is the required relation about linear acceleration and angular acceleration. In vector form, what we can write, that is vector A is equal to vector alpha cross vector r. What is this form? This is in vector form. We have 1 mark question, we have 2 mark question also. Sometimes in HSC board, question may be asked, write the vector form of linear acceleration and angular acceleration. So what is the vector form of linear acceleration and angular acceleration? Vector A is equal to vector alpha cross vector r. Okay, watch it carefully.